strategy. We take a problem which is expressed in unfamiliar terms and we make up a simpler problem. We do the simpler problem and we copy across the method from the simpler problem to the harder problem. So here's a strange question. I buy a bike for £2 and I sell it for £3.50. What % profit is this? Well, let's just change it to some simple numbers. If I bought a bike for £20 and sold it for £25, then the profit would be £5 and the percentage profit would be 5 over 20 times 100. So all I have to do is the same thing, just instead of the 20, I have root 2. Instead of the 25, I have 3 root 50. The 5 came from 25 minus 20. So for me, the profit, so this is the fake question. This is the real one. If the profit came from 25 minus 20, the actual profit will come from 3 root 50 minus root 2, which is 3, 25, 2, which is 15 root 2 minus 2, which is 14 root 2. And what did I do before? I took the profit, I put it as a percentage out of the original. The original is that. I times it by 100. So the answer is 1400%. Question number 2. I have to graph this strange looking expression. Well, imagine it had been this. I would have done it with a quick table. To get the intercepts, I would have made x0. I would have covered that up and I would have divided 6 by 2 and I would have got 3. Then I would have made y0. I would have covered that up, would have done 6 divided by 3 and I would have got 2. That's what I do on the easy problem. That's what I'm going to do on the strange problem. So, quick table again. So, x is going to be 0. Cover that up. Sorry, that's too long. So how do I get y by itself? I divide both sides by root 8. Rooty divided by rooty is rooty, so that's root 4, which is 2. Now, when y is 0, that gets covered up. Divide both sides by root 2. Root 32 divided by root 2 is root 16, which is 4. So our graph is very simple. It's 0 along 2 up, 4 along nothing up. And there's the graph. Question number 3. Divide 180 in the ratio root 3, root 27, root 75. Well, normally you get something like divide 100 in the ratio 1 to 4 or whatever. What do I do there? I say 1 to 4 is 5 parts. That comes from adding. Then I say, therefore, each part is 100 divided by 5 equals 20. That's dividing. And then I say, therefore, 1 dot dot 4 is 20, 80. And that's multiplication. If I add, divide, and multiply in the easier problem, I'm also going to add, divide, and multiply in the harder problem. So let's do the real problem. So in the ratio like this. Now add them up. Just going to simplify this. So that's 9 root 3 parts overall. Therefore, it's 180 divided by, so So in other words, if you divide 180 by 5, you're going to divide, sorry, if you divide 100 by 5 in the simple problem, you divide 180 by 9 root 3 in the harder problem. And that's 20 over root 3. In the simple problem, I then take what each part is worth and I multiply it by the constituent parts of the ratio. So 20 times 1, 20 times 4. I'm now going to do 20 over root 3 times root 3. 20 over root 3 times root 27. 20 over root 3 times root 75. I think they were the parts. Yes, they were. So simplify this. That's 20. That's root e divided by root e, which is root 9, which is a 3, so that's 60. Root e divided by root e is root 25, so that's a 5. So there we go, and they add up to 180, so that's good. So that was question number 3. Question number 4. Same sort of question again. Okay, so 2x minus 1 plus 3x plus 1 plus negative 4x plus 10 parts overall, i.e. x plus 10. In the simple problem, we divided 100 by 5. We're now going to divide x squared minus 100 over x plus 10. I'm going to factorize that in order to simplify this. So it's x minus 10 per part. And then what I did in the simple problem was I took the constituent parts of the ratio and I multiplied them by this. So the split is 2x minus 1 times x minus 10, 3x plus 1 times x minus 10, and negative 4x plus 10 times x minus 10. So that's question 4 done. Question number 5. x 0, root 27, and this. Well, I'm going to use this template for the equation of a line. All you need is a point it goes through. So I'm going to use that one. An m can come from a formula. The formula gives you a fraction. Top of the fraction is this minus this, the y coordinates. Bottom of the fraction is this minus this, the x coordinates. So simplifying, that's root e divided by root e, that's root 9, which is 3, so it's negative 3. And there's your equation. Okay, so here's a strange problem. Now, what would the simpler version of that problem be? It'd be something like this. Just make up random numbers. What would I do there? I would subtract those powers, and then I would multiply those powers. If that's what you do in the harder problem, in the easier problem, that's what you do in the easier problem. That's what you do in the harder problem. So I subtract in 20 and 7. I therefore subtract those. I can simplify those. Now, if I multiply the 13 and 3 to get 39, I now multiply this and this. That's non-rooty times non-rooty and rooty times rooty, which is x to the power of 40. So a simple version of that problem would just be like this. I'm going to use the y equals mx plus c template for this. The c is the y-intercept, so that'll be 5. The gradient, the m comes from tucking a triangle. the height of that triangle becomes the top of a fraction, and the width of the triangle becomes the bottom of the fraction, and we're done. So if that's what I do on the easy version, that's what I'm going to do on the harder version. So I get y equals mx plus m to the power of 101. The fraction is m to the power of 101 over m to the power of 51. I don't need the negative because that line is sloping up from left to right. And to simplify that, you just subtract the powers. That's that one done. What's the mass of a 3 times 10 to the 8 litres of material stored with a density of 5 times 10 to the power of 4 grams per litre, expressed in standard form? Well, a simple version of that problem would be, what's the mass of, 10 litres of material stored at a density of 4 grams per litre? Density equals mass divided by volume, so therefore mass equals density times volume. In other words, I would times those to get 40 grams. If I times them to get 40 grams, then I'm going to times these to get 40 grams. Ratio, well, normally when I simplify a ratio, I search for common factors. There aren't any here. This question there are now, you divide everything by 3. So if you search for common factors on this simple problem, then let's search for common factors on that problem. The way to do this is to factorize. So, divide everything by x plus 1. This is the simplified ratio. Question number 10. Okay, so normally when I work with surds, I try to split stuff up so that I can write a square root symbol separately. So let's try that. So I'm going to split stuff up. When I do a simple problem, I'm always trying to find square numbers. That's why I've tried to get all these square numbers here, because square numbers are easy to square root. They just become what they were pre-squaring. So it's a, copy down, square root of a squared is a. That's an a, that's an a, that's a root a. Simplifying, that's this. Okay, now this is weird, but it's like terms. So if I had, 3x plus 3x, so that's my 3, that's my 3, that's my x and my x, that's my x, I would just go 6x. Or if I had ax plus ax, I just have 2ax. So therefore, what's playing the role of x in my example? Root a. What's playing the role of a in my example? A squared. So the answer is going to be 2a squared root a. Question number 11. Find the surface area of a root 2 by root a by root 32 cuboid. So let's imagine it was just 2, 3, 4. There'd be a front and a back. 2 times 3. The 2 expresses the fact there's a front and a back. There's a right and a left, so that's 2 times 2 times 4. And there's a top and a bottom, so that's 2 times 3 times 4. And then you add them together. So in other words, you need 3 multiplications by 2 of every possible pairing within this. So for the actual hard problem, it's 2 times root 2 times root 8. 2 times root 8 times root 32. 2 times root 2 times 32. We're good to go. That's 2 times a root 16, which is 2 times 4, which is 8. That's a 2 times a root 56, root 256, which is root 16. So, which is 2 times 16, which is 32. And that's 2 times root 64, which is 2 times 8, which is 16. So the answer is 56. In question 12, I have to factorize this. Now, these must be even numbers. So what would I do if I had to do a question like that? Would it be different to 2 squares? So it ended up being same bracket twice, once with a plus, once with a minus. And what happens is that this ends up being half that. That ends up being half that. So therefore the answer to what I have, what's half of 2m? M. So same bracket twice, once with a plus, once with a minus. Let's just check that. If I did that times that, it will be x m plus m, which would be x to the power of 2m, which means it's good to go. Now, question number 13. So m is this, n is this, and we have to find the product of those. Well, that looks like standard form to me. So if it was just this, I would go that times that, and then I would add the powers on those. So that's what I'm going to do here. I'm going to go mn equals this times this, which is root 16, times 10 to the power, and then I'm going to add those. So that's 8 times 10 to the power of root 25 root 3 plus, so that's a 300. 100 root 3 equals 8 times 10 to the power of 5 root 3 plus 10 root 3. So it's 8 times 10 to the power of 15 root 3. So question 14. Okay, same thing again, but this time we have to divide. So I'm going to go this divided by this, and then I'm going to subtract those powers. So x squared plus 5x plus 6 over x plus 2 times 10 to the power of x squared minus x plus 1, x minus 1. Now, I'm going to simplify this through factorization. And I'm going to simplify this by expanding that bracket. So I can cancel those. That minus that is blank. Taking away a negative is adding 1. So there's our answer there. So it's 10x plus 3. Oh, sorry, it told me to express it in that form. So that is good. Okay, question number 15. Find the result when 50 pounds is increased by 100 root 2%, then decreased by 100 root 2%. Okay, so simple problem. Increase 50 pounds by 8%, then decrease by 8%. Now, what do I do with these? Well, the fastest way is to use a decimal multiplier. You go 50 times 1.08, but how do I get the 1.08? The reason why I'm asking that question carefully is so I can apply the same method to the harder question. I get a decimal by dividing that by 100 and adding it to 1. And then I times by that, and then I do the same thing, but this time I turn that into a decimal and subtract it from 100. Sorry, from 1. So it's the classic 50 times 1.8 times 0.92. So do that on a calculator. What about the harder problem? Okay, well, how did I turn the 8% into my number that needed to be added into 1? I divided by 100. So I'm going to do that on this as well. Divide that by 100 and you get root 2. So it's 50 times 1 plus root 2. And now, how did I get my 0.92 here? I took what was in front of the percentage symbol and I divided it by 100 and I subtracted from 1. So what's in front of the percentage symbol? 100 root 2. Divide that by 100, you get root 2. Subtract that from 1. Now, this is just same bracket twice, 1 to the plus, 1 to the minus. That's difference 2 squares. So there you go. It's negative 50. Okay, question 16. Volume of a trapezium, volume of a trapezoidal prism is the area of the front times how far it goes back. Here's my simpler problem. What would I do here? I would go this plus this times this halved. That's the area of the front times how far it goes back. So I'm going to do the same thing, just with the harder problem. What's playing the role of the 6? 3x plus 1. What's playing the role of the 8? X plus 3. So that bracket expression has become this. What's playing the role of the 5? 4x minus 4. There's still a 2 there because that's part of the method. What's playing the role of the 10? This expression here. Okay, let's simplify that. So that's 4x plus 4, 4x minus 4, all over 2, times 10x. Okay, that's same bracket twice, 1 to the plus, 1 to the minus. That becomes difference 2 squares. Cancel that, cancel that, cancel that, and that. So the expression for the volume is 5x. Okay, now complete the square on x squared, so 17, x squared plus 2 root 5, x plus 7. So, simpler version, x squared plus 3x plus 2. So what do? Well, I bump out third position, so I'm going to do that here as well. Now you fill the third position. How do you fill the third position? You halve this, and then you square it. Half of 3 is 3 over 2. Square that, you get 9 over 4. And you can't just randomly introduce it. You have to subtract it in order to enable you to say that you haven't changed anything other than the look of the problem. You don't want to change the fundamentals of it. You just want to change its look. So let's do that here. Halve this. What is it? Root 5. Square that. You get 5. And what do you do now? You factorize the triple. Easy to do. You just remember what you had at the halving stage. And then you simplify these. So that's 2 minus 2 1/4, so that's negative 1/4. So what did I have at the halving stage? I had root 5. And now simplify those. There we go, done. Okay, 18. Y is proportional to x. Simple problem. If x equals 2, y equals, 4. Find y when x equals 5. Okay, what do I do here? I go y equals kx. I put in my example and I find k. So then I have a new improved version of that. It used to be y equals kx, now it's y equals 2x because k equals 2. And now I actually answer the problem. Okay, so I'm going to do that with a harder version of the problem. I still write y equals kx, but my example is no longer 2 and 4. It's now root 2 and root 18. Just like I divided both sides by 2 here, I'm going to divide both sides by root 2 here. Root 18 divided by root 2 is rooty divided by rooty, so that's root 9. So k is 3. So y equals kx becomes y equals 3x. Now over here I got told that x equals 5, so I put a 5 there. For me, I'm going to put an m where x is. And there's your answer. This is a strange looking problem. You can do it in a number of ways. You can express it as a fraction and then get rid of the fractions within fractions by multiplying patiently by the mini denominators. But just as an example of the smaller and simpler strategy, I'm going to regard this as a mixed fraction problem. This looks to me very much like 2 1/3 divided by 5 2/7. So that's the 2. That's the third there. The reason why I've got it in brackets is so it's clear that all of this has been divided into the first expression. And the reason why I've got a plus is because mixed fractions is one of the exceptions to the principle that if you write two things next to each other, it's regarded as multiplication. When we write a fraction next to a whole number, we regard that actually as an addition, which is a rare example of that phenomenon. So anyway, when I look at this, I see mixed fractions. So, how do you do this? Well, you convert it to impropers first. You go this times this plus this, and then you transfer this down. This times this plus this, and then you transfer that down. Okay, so that's what I'm going to do with the real problem. I went this times this plus this. So this times this is root 100, which is 10 plus 1. So that's 11. Transfer this down. This times this plus this, therefore this times this plus this. This times this is root 81, which is 9, plus 2 is 11, by coincidence. Transfer this down just like you transferred the 7 down. Now it's just fractions wrap. Done. Okay, now, question number 20. This is nested similar triangles. Simple version of the problem would be, I don't know, 2, 3, 4, x. Advice is to copy the triangles out separately. So that'll be a 2, that'll be a 5, that'll be a 4, that'll be an x. Now, because the lines are parallel, these are similar triangles, which means if you see doubling in one place, there'll be doubling in the other place. And look, there is doubling there. So if a 2 becomes a 4, that's doubling. So a 5 will become a 10. So x equals 10. That's the method for the simple problem. It's also the method for the harder problem. Smaller triangle, x plus 3y, 2x plus 6y. Bigger triangle. You've got to add that and that. So 6x plus 4y, and that's an m. Okay, so what do I spot? Well, here, that's doubling. So this will be doubling. So m equals 2 times 6x plus 4y. Done. Okay, question 21. Simultaneous equations. Okay, so simple version of the problem. Okay, so what do? I try to get a match so that I can do 3 additions or 3 subtractions and thereby see something disappear. So I think what's easy to turn a 2 into that's also easy to turn a 3 into? 6. You achieve that by tripling the top and doubling the bottom. And then you do 3 subtractions. That take away that is blank. That take away that is 7y. That take away that is 15. So y equals 15 over 7. Okay, so let's apply that method to the actual problem. Root 2y plus root 27x equals 11. Root 8y plus root 3x equals 7. So, I asked, what's easy to turn a 2 into that's also easy to turn a 3 into? What's easy to turn a root 2 into that's also easy to turn a root 8 into? Well, how about just root 8? How do you do it? You times by root 4. So that'll become a root 8. Root 4 is just 2, so I'm going to make life easy for myself just by writing that. And that. And now I'm going to do 3 subtractions. That take away that, 15. That take away that, blank. Now, I usually don't encourage people to write lots of workings on the side, but I think it is legitimate here to just calmly find out what this is. So it's 5 root 3. So therefore root 3x equals 3, so x equals 3 over root 3. Okay, I'm now going to try the problem again. This time I'm going to match the x's. An alternative is to substitute that back in, but because it's fractions and it's got roots in it, there's a higher chance of making a mistake. So to find y, I'm just going to eliminate x this time. So what's easy to turn a root 3 into that's also easy to turn a root 27 into? Well, how about just root 27? We achieve that by multiplying by root 9. So here's the original top line copied out. And here's the bottom line about to become a root 27 by timesing by root 9. Root 9 is just 3. Here's the 3 subtractions. That take away that, 10. That take away that, blank. That take away that, I'm not sure what that is. Just to do that off to the side. So that's 5 root 2. So root 2y equals 2. So y equals 2 over root 2. And we're done. Okay, in this question, a bag contains m blue and n yellow marbles. One marble is selected at random from the bag and its colour is noted. It is then returned to the bag along with k other marbles of the same colour. A second marble is now selected at random from the bag. Okay, so I think this is a true situation. And let's pretend there's, what was it? M blue. Let's go M blue. N is yellow. Let's say that's just 2. And K is 5. Okay, so step 1 is just blue and yellow. So 3 out of 5, 2 out of 5. Then come K other marbles of the same colour. So this is stage 1. This is stage 2. So K for me is 5. So it was, if I picked a blue, then it's now 5 blues that get put in. So it's 8 out of 10. Whereas down here, okay, I don't need to make this as a separate stage. I can just say that in stage 2, in stage 2, if a blue got pulled, there will now be 10 balls in the bag
because 5 extra blue ones got pulled in. But there'll still be 2 yellows, so it's now 8 out of 10, 2 out of 10. If a yellow got pulled, 5 extra yellows will get put in, so it'll be 7 out of 10, and there'll still be the original blues there. So the summary is blue, 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 Y, blue, Y, Y. Multiply the fractions, you get 24 over 50, 6 over 50, 6 over 50, and 14 over 50. What's the probability that the second ball picked is blue? It's these two items on the summary that we want. So it's 30 over 50. If that's the method for the easier version of the problem with the numbers, it's also the method for the algebra version of the problem. So the structure of the problem won't change, so I can just copy out my tree. I'll still be interested in those two. I'm going to ignore those, so therefore I don't need to work out these branches. Okay, so I had 3 out of 5, but now it's m and n, not 3 plus 2. So it's m over m plus n. Down here, it's not a 2, it's now an n, so it's n over m plus n. Now, this 10 was 5 more than 5, in other words, from adding the k. So it's not m plus n anymore. In other words, it's no longer the 5, it's now the 10. In other words, m plus n plus k. And it wasn't 3, it was 8 because we added an extra 5 blue ones. So for us, that's the m plus the original k. We don't need this one because remember we're not interested in that one. The easy version of the problem showed us that. Now, again, up here, just going to take a shortcut here, that matches that, so I'm just going to transfer that down. That, yeah, it's just the same as that. See how that 3 matches the 3? That makes sense because down on this branch, it was a yellow that got pulled out first, so the number of blues is unchanged. It doesn't have that extra k marbles added to it. So, if over here I multiply the fractions to get the probabilities, that's still the case here. Now, if I add those two probabilities before, then I definitely add them now. We've got a common denominator, so you can just transfer the common denominator to a single denominator and then add the tops. Now, that can probably simplify. Factorize the top. Cancel. So the answer is m over n, m plus n. Now, interestingly, that does not feature the k, so in fact, the addition of the k balls was irrelevant. It doesn't make any difference. As coins are tossed, the first has probability of landing tails, this weird fraction. The second one has probability of landing heads, this weird fraction. I converted those weirdo fractions into just straightforward ones, which I put into the diagram thus. 2 over 3 led to 1 over 3 just by subtraction. I need to make sure that this plus this is the same as this. My 1 over 4 immediately led to a 3 over 4 on the other branch because this plus this needs to add this, therefore the 3 can come from subtraction. We're asked for the probability of the head then a tail, so all these fellows are actually unnecessary. and we just do it by multiplication. So that times that. Okay, now if that's how we do the easy problem, it's also how we do the harder problem. That came from the question. Therefore, that probability has to be that minus that, just like this probability, this numerator is that minus that. Equally, these two fractions need to add to 1, so the numerators need to add to the same as the denominator. So we can just say that minus that becomes that numerator. Now we do that times that. So that times that is this, that times that is this, which becomes this. And the final point was just to realize that that's actually a negative probability because I wasn't careful enough when I constructed my question. Sorry about that. Question 24. Okay, so this is a strange situation. What would I do normally? 2 to the power of 2 to the power of 2. I'd normally multiply those, and then I would just do the power. So that's what I'm going to do here. I'm going to go root 2 to the power of root 2 times root 2. That's root 2 to the power of root 4, which is root 2 to the power of 2. And then, as I said, I would just do the powering. Root 2 squared is root 2 times root 2, which is root 4, which is 2. So that leads to the quite amazing fact that something as complicated as this can just come out to be something so simple. Now, the same principle at work here in question number 25. Check this guy out. Now, let's just do a simple version of this problem. Okay, so that is definitely this times this. That is definitely this times this. And then finally one last multiplication. Okay, so it seems to me that all you have to do is multiply these four. If that's what you do for the simpler version of the problem, that's what you do for the harder version of the problem. But we have to be careful here because it's very hard to multiply these algebras. But what this demonstrated is that if it's just straight out multiplication, it doesn't matter what order you do it in. So I'm going to multiply that and that first. That's just difference of 2 squares. And I'm going to multiply that and that second. And now I just have to multiply those, which is FOIL, I think. And there's your answer. Now, so that was question 25. Question 26. After an X% increase, the quantity is 10,000 minus X squared. Find the original amount. Okay, so if it was after a 5% increase, a quantity is 120. Find the original amount. Well, the way I do this is I go 105% is 120, so therefore 1% is 120 over 105, therefore 100% is 120 over 105 times 100. So if that's what I do on the easy version, that's what I'm going to do on the harder version. So 100 plus X% is 10,000 minus X squared. Now I'm always telling people to be on the look out for difference of 2 squares. So therefore 1% is, dividing both sides by this, is 100 minus X. So therefore 100% is 100 times 100 minus X. And that's done. Question 27. Last question. Okay, construct a histogram for this data. Okay. So, simple version of the problem. We just have some sort of business with unequal class intervals. And what do? we lay down markers and put rectangles between these markers. The rectangles need to have areas indicated by this. So we divide the area by the width to get the height. 3 divided by 2 is 1.5. That's the first rectangle. How wide's that? 1. Area of 4 divided by width of 1 is a height of 4. And there we go, that's our answer. So let's just think, how did I get this? I did divisions to get the heights, and to get my widths I did subtractions. So that's what we're going to do for the hard version of the problem. Okay, so let's lay down the markers first, because that's what we did before. We had 0, 2, 3. We need root 2, 2 root 2, 3 root 2, and 5 root 2. So let's just make it go up in root 2's. Okay, so between 2 root 2 and 3 root 2, so here I need to put a rectangle. How high should the rectangle be? It should be that divided by the difference between this and this. This minus this is root 2. Root 2 divided by root 2 is 1. So that's how high it should be. Let's just check. What's the area of this? That width is root 2. Root 2 times 1 is root 2, so that's sweet. Now, that is a width of 2 root 2. So I go that divided by that. So 4 root 8 divided by 2 root 2. Non-rooty divided by non-rooty is 2. Rooty divided by rooty is rooty. So that's 2 times 2, so it's